To continue from right here. There was one question I wanted to review. I think I was the last one that we did. Was the last question that we did?
Page 20.
Page
20.
20. Right. So before we go into putting them together, here's what we're gonna try, Faith. Faith, I'm gonna try to give you this is page in the same handout I sent you all, right? Number 5, page 26. Let's go in reverse. Page 26, right? Let's go in reverse. Let's take this graph and see if we can find the gain, and then they want an equation and explain what happens beyond 300 and then sketch back the graph. So we're going in reverse here. Let's go in reverse and sketch the circuit for this graph. Last week we did the graph and then get the circuit. Sorry, circuit and then get the graph. Today we're going backwards, right? So number 1, could you all tell me the maximum supply on this graph? What's the maximum supply on this graph? 6, very good. So VS is positive 6 and what else? What's the lowest value? Minus 6, very good. Right, gain. How will you get gain from this graph, one Jacob? Huh? V out and V in, very good. What else we can do from this graph? What else we can do? From the graph. From that graph, yeah, that graph. How we could get the gain? Anybody can help him? Gradient. Gradient. Find the gradient now. This is millivolts, right? And after you get your gradient and you get your gain, sketch what the circuit might look like. Got again. Got again.
Yeah, negative 0.
Negative.
0.
That's something wrong. 0.03. Now, I'm a little too small. Remember, this is millivolts, eh? Millivolts. No, right there, good, right there, good. Oh, right there, good. See right there? Remember, that's what it's about. Right, so you can pick any 2 points you want, right? You can pick 0, 0. I would have picked 0, 0 and point up here. Minus 200 millivolts and positive 6. So I would have used those two, right? 6 minus 0 over minus 200 by 10 to the minus 3 minus 0. Right? And I would have got minus 30 or minus 300. Anybody get that? Minus 30?
Yes, sir.
Minus 30. That's again, right? Cristiano? Follow went on. Sure. So here's the problem now. We had to sketch a graph. Sorry, we had to sketch a circuit. We had to draw a circuit, right? How are we doing that? Right? We know what the symbol is. We know we know the plus is connected to Earth. We know that here is we know that the top is 6 volts. No, the bottom is minus 6 volts. Right? What missing? Reese? What missing there from that circuit? The resistance. Right? And the resistance have to equal to how much? The resistance values when you work it out have to equal to minus 30. What you'll choose? It don't matter what you choose. They didn't give us a range. So we can even use 30 kilo ohms and 1 kilo ohm. 310. Actually, let me use something more typical, right? 310. Okay. Everybody clear now? That's just going in reverse, right? So here's what we're going on to do now, Attilia. What we're going to do now is we are going to try to put 2 op-amps together. All right? So I want you to head up cascade cells. So I want you to head up cascade cells, right? Sorry, not cells, cascade op-amps. Right? Here's what I'm gonna do. I'm gonna take this op-amp and I am going to connect it to a next op-amp. And now we have to find the overall gain. Any ideas how we could find the overall gain? How we could find the overall gain? Gain is still what? Gain is still V out over V in. Right? So we need this whole value and this value to figure it out. But in terms of the resistors, we need other help as well. Yeah? Any ideas? So I'll show you a long thing and then I'm a shorter way to work it out. Right? I'm going to show you the long thing first. So this input goes into here and it gives you an output. Everybody okay with that? And then the output from here becomes the input for here. Everybody okay with that? So I just changed some numbers, right? Let's put this as 1. Let's put this as 2. Let's put this as 3. And let's put this as, right? So we said that the output from this fella becomes the input here, right? So we said that the output from the first gate, from the first op amp, let's call that A, let's call this B. The output from A is the input from B. That's okay? So let's find P out again. P out is what? Gain by V in. So to find this V out, I need the gain of the first op amp multiplied by the original V in, right? Yeah, the original V in. Right? Now, how do I get V in? V in is equal to the final V out over the gain of P. Everybody okay with that? Right? So what do I need to get to find the gain again? I need V out and V in. So I'm just going to make V out and V in the subject. So that'll be V out over V in. The V in go in here and I'm bringing across this. The gain of A by the gain of B. You recognize that? So all I need to do is to find the gain in A and multiply it by the gain in B. You see that? Okay. So cascade cells are here. Find the gain here, find the gain here, and multiply it. That's all. That's okay? And just to remember, what's the gain here again? Minus R2 on R1. What's the gain here? Minus R4 on R3. Minus will cancel that. So again, positive R2, R4, R1, R2. That's okay? You recognize that the final phase is positive. You okay with that? So whatever you have here, to switch and then switch back here. Are you with me there? So in short, to make it simple, when you have cascade cells, you multiply the individual gains. Okay? And if you know the gain, you can find V out if you have V in. Yeah? Cristiano? Yeah? Mills. Who's Mills? Sent online? We need nah, that didn't come today.
The downside of it.
Can come to it? So Reese here, Pete here, Jacob here, Cristiano here, Chapman here, Eden Roberts. Eden. Tyrese, who say Tyrese? Vinesh here, Redson here. Dylan, you were here last week. Yeah, so Attilia, Porter here, he is. Darion here. Darion not here, Rasnell here. Wait, Daniel, are you going to? Shazana. Right, you this man, Jacob, boy, he must be here. Right, how many people just right? Right, let's jump down to question. Same page, right? I just switching it online. Adriana, Rohit, she was here last week. Ah, he is online.
So you see, you
You knew?
you talk that
Stop.
society.
Was it nice?
Society.
Hurry. Serious? No, I answered them.
Say no for reason.
I think so. Tomorrow. But they know that. They know that.
Really, sounds like you got a lot for.
You got it? Right. Here we have an upper and they want B out. They give you B in 0.3. What do you need to get if you have input and you want to get output? So you want to get V out, right? And you have V in. V in by what will give you V out? So you have to go and find the gain. Okay? Hurry up. Try that fast. Who gets first win? Win. Like win. What time again? What's up?
The door is 7.
How about it?
Door is
Send it down. Eight o'clock. It's not something. So you have real time.
Traffic.
How's that? Got it done? Oh, yeah. Work out the gain. Find the gain on the first one. Gain of a cascade cell. You gotta find the gain on the first one, gain on the second, just multiply. Yeah. Just like the example, you just put in the resistance values. It's page. It's page 25. Huh? Keep it like that, divide. Alright, time up. Right, help me out here. What's the gain for the first up arm? What's the gain of the first up arm? Right, the gain of the first up arm that will be 150 divided by 50 is a minus. So I got 3. Yeah, minus 3, sorry. The gain of the second op amp is minus 150 on 30, that's minus 5. So the gain in cascade will be minus 3 by minus 5, which is 50. So the final answer I got is input is minus 0.3 and the gain is minus 5, which is minus 1.5. That's okay? Oh, sure, 15, sorry. How much is that? And a man say, yeah, that's it. 4.5. Huh? No, the kilo will cancel. The kilo ohms will cancel. Online, are you okay with that there? Y'all got the minus 4.5. Yeah. Kalina, nice. Yeah, okay. Everybody clear with that all, yeah? Alright. Let's go again now. Okay, then follow and go next. Yeah. 110. From there, looking at them. Yeah, I don't know what happened.
Oh, that is to be careful.
Yeah. Yeah, here with the error into start up the result.
Actually.
Isn't it right? All right, let's change now. Next heading. Next heading, summon amplifier. Huh? Summon, S-U-M-M. Huh? Yeah, that's a one board casket. Quick question, Jacob, because I have you paying attention there for what type of op amp is this, Jacob? Inverting or non-inverting? Very good. Because the positive connected to Earth. Right? Inverting op amp. So this is a special type of op amp. Here's how it's different. Watch it here. You all recognize that the input is 1, 2, 3. So this amplifier can handle 3 inputs. Like for those who into music and things. And the amplifiers can handle a microphone and different little thing. Right? So here's an example of where you're taking 3 inputs and again 1 amplified output. Okay? So the subheading for this one is summon amplifier. Right here for those who have been trouble spelling it. That's it, you right. Joy, please.
So what we use.
20.
How.
Finish? Right. So what we need to get while you're drawing, we need to figure out how to find the output for this op amp.
So.
Huh? Basically. Huh? For that. Man saying quite early, man. Right. So how do we find V out? So to find V out, right? To find V out, we want to be able to incorporate everything, right? So here's how it looks. It's an inverting op amp here, close it. It will be RF, I'm putting the minus sign on the outside, right? RF on R1 multiplied by V1. RF on R2 multiplied by V2. And RF on R3 multiplied by V3. Right? So you have to combine all the inputs and all the resistors to get the final output. So let me add you again. Okay. Yeah, I can give you the circuit, yeah, join that. Sometimes I'll give you the circuit and do the calculations. But it's the same thing, except it has two inputs. Instead of one input, it have two. Alright? What you'll see in the formula, excuse me. Whatever. Right? If you look at the diagram, right? What you will recognize here in the formula that you're using RF all the time, and you're using the input and the corresponding resistor underneath here. That's okay? You're seeing that? And when you work out that whole thing, you get one output. Right? That's the amplified output. Are you okay with that? Let's put some numbers there. Anybody write in? Okay, then bring it hand over there. Then put it on the LMS, forward that to this subject. I think we got the email. Play it down the LMS. Like the sun go up, right? The way it goes. Alright, watch this one here. If you look at this one here, how many inputs it have? Two inputs, right? B1 and B2, and you're seeing the resistors, right? So what would the formula look like? You can do it in your head. What would the formula look like? V out is equal to what? Right, but it have values. Tell me what it is now. 200 over 40, which is 5. So that's 5V1 plus what? Which is 2V2. That's it? Yeah. That's the formula? Yeah. So all you have to do now, Jacob, is to plug in what is V1 and plug in what is V2 and you're done. That's right. That's right. That's right. Okay. And they did it here for you. Just do me a favor, find V out there now using those values. Right, so that on this page 29. That's example 1 on page 29. Find V out there, please. Once you get Chinese. Chinese. You know what they call them now? It's a Chinese chip. What do they call it? Huh? Chinese. Chinese, where you get to eat?
Don't say that on recording, please.
So how do you know who it is?
And
And then how do you know who it
It
is?
was Nicholas, Nicholas Paul.
Well, it's somebody Chinese.
Yes.
But how do you know who it is?
Wait. Some people know this one.
Again, how do you know? Anyway, yeah, one solid again. What will that be? 5 by 0.5 plus 2 by 1. How much is that? Minus 4.5. Right? That's it. That's all we're doing. Nothing too difficult there. Try this one. 1.2 and 2.5. Last one. Try that now. 1.2 and 2.5. One point two and 2.5. Negative. 11. Is that a problem? Is that a problem? Yeah, why?
Oh, second outside the limit.
Outside the limit, right? So that's saturation. So what would the answer really be? -9. That's okay? It's outside the limit, so it will now be -9. Everybody okay with that? All right. Any questions there online? Bills, all okay? All right. Right. Let's do a little Sylvester here and read. Let us do watch here, right? We're going to reverse engineer the graph now. Do that there, please, audio. I try to zoom in there for you, right? I want you to re-engineer it here. The next page. Now, 31. That's the formula. I want you to re-engineer it. 41. I want to draw the graph now. Go in reverse and draw what the circuit I mean.
Hey, I'm yes, I have. Okay, I'll put it. Okay.
Oh yeah. Yes, go backwards. So this circuit I'll give you that and they give me a range. No values less than 10, no values bigger than 3 and 4. Reversing.
So because the first
How many inputs you have? It's circuit gun the same.
Oh,
That's the value with difference, right? Yeah, so this circuit. I say circuit. Are you putting your values? It doesn't matter. Once your values fall between 10 and 300. Hurry up. Take up your done. I'll go pick up. Right now, take up. Other people have that circuit in the loop. And now put in your values. It's 3, 4, and 3, 4.5. That's all you have to focus on. You gotta get 3, you gotta get 4.5. Something divided by something giving you 3. What could give you 3? Give me two numbers that could give you 3 between 310.
300.
300 divided by 100, yeah, that could work. But remember, yeah, you gotta get 4 using that value and so on. Take it now.
So you guys,
Well,
something good.
it's something good 12.
Yeah. Yeah, finish.
Right, so time up. So basically, I would have choose, as Sylvester was saying, I would have choose 120. Right, and then here will be 40. Here will be 30. And here will be 240. And that worked out nice. 120 divided by 40, that'll give us 3. 120 divided by 30, that'll give us 4. 120 divided by 240, that'll be a half.
You can have our system, and that's.
Well, yeah, didn't specify it. But really and truly, that is the whole numbers. Right? But yeah, decimal can work as well. Right, you just follow up on. Okay, so that brings us to the end of inverting up arms. Oh wait, that's true, Pete. Pete said that there's an next part underneath that thing.
Yeah.
Oh no, there's no part underneath it. What are you talking about?
Are you doing?
That was the last one.
Okay.
Ooh, this is a really nice one. Hello, try this one. There was something like it's not past people. Let's try this now. Page 32. Try this now, please. Huh? This came in a past paper. But instead of 4, I think it had 2 or 3 of them. Online, you're okay with the last one? Vinay? Oh no, you might have been at a loss. Darian. Daniela. You're okay with the last one? Yeah? Alright. This one here, it's a little tricky, but it came as a past paper, right? Try this, please. This is page 32. Yeah. Page 32. Hurry up, please. Dylan. Question, please. It's all the plane there, still coming and take all the phone. Huh? 1 hour. Hurry up, try it quickly. Right, so the circuit below. Oh wait, you know, set the sample. You have what's that? You know? You have a same mind of what's that? Idea. Somehow what's that? Are you in the group? Yeah, that's good. Alright, somehow what's up and I'll send it. You know. Right. Let's see, right? So the circuit below is in digital. You ready?
Yes, sir.
What's here, right?
So I'm trying to start for you.
Huh?
Register.
Right? The circuit below is a digital to analog converter. Right? Input A, B, C, and D are connected to a parallel cable carrying a digital signal. For a 1, the voltage rises to 5 volts, and for 0, it remains at 0. The input A is the significant bit in the digital number. That is 8 digits, D will be the last, right? Like 8, D will be the last. Nice. Write an equation for the upper V out. Everybody can handle that? Right? Tazana, tell me what V out there. So V out will be, I'll leave the minus on the outside, right? Right, 160 over 200 BA. Sorry, well, let's call it A, right? Plus 160 and 400 B plus 160 and 800 C plus 6. Yeah, plus 160 over D. Nice. That's what the formula, that's what it looks like, right? Let's go to the second part now. Part B. If the input is 0010, if the input is 0010 and BC is equal to 5, what and the other inputs are 0, what is the output voltage? So what is A again? Looking like it up at faith. What is what A again here? In this example, A is what? 0.00. Mom, I gave it to you on your phone. I wonder why. A is 0, B is what? C is 5, and D is 0. Right? Because remember, 1 represents 5, right? Multiply it out, tell me why again, huh? 1. 1? Okay, 1. So therefore, your V out is 1 volt. Right? And you do the same thing for the others underneath here. All right, nice. Right? And you can do that same thing for all of them, right?
Yes, sir.
Okay, so that's one more thing I want today. I want to focus on the head of non-inverting up amp. Last thing. Last thing for today. Head up non-inverting up amp and draw that circle there. This question goes to Binesh. Binesh,
Yes, sir.
how do we know that that is a non-inverting up amp? Besides the fact that I've told you another thing. The positive side not polluted. Very good. Negative side is neutral. Very good. Okay, let's put this phone there. So that's circuit there, and that's a non-inverting after.
She read the side.
No, I didn't.
The input is connected. The input is connected. Good, then just connect the input side. Right. So we know how to identify a non-inverted, right?
Yes, sir.
So I'm using the same handout because I have 4 nice examples here. Here we have 4 examples. I'm going to zoom into one. Don't draw them, it's in the handout. All I want to know is inverting or non-inverted. Though I really did because I didn't give any formulas yet. Wait. Shh. I will pick on some people. Alright, Yash. What is this here? What's the name of it? Inverting, non-inverted. Non-inverting because the input is run through the right, and the inverting connected to earth.
Yeah.
All right. Nice. So number 1 is non-inverted. Number 2 in the handout, right? Let's pick on somebody online. Darian. What is this here, Darian? Inverting or non-inverted? Darian. Darian. Stop, sir. Wow, let's see how that's going. Yeah, tell me that.
684. Okay. 9137.
Non-inverted now. Doesn't Darian. I can't say that fast. No message? Oh, you're okay. All right. Right. right? Darian said non-inverting, correct, right? Because the input run through the non-inverting and inverting connected to it. Try it up. Try this one either. Try C. Inverted. Whatever you with that, inverted. Look at C, inverted.
Oh, yeah.
Yeah,
Can I explain that?
which one?
Fine.
This one, watch it here. Because the positive, which is a non-inverting terminal, connected to it, and the input is run through the inverting terminal. Watch it good. Inverting up on. All they do is they just draw the feedback underneath. That's all. And they flip the positive and negative to confuse you. See that? So they kind of flip the whole circuit upside down. And last one, T. I pick somebody online. Call Darian again. No, okay, my love that. Kalina, what do you think this last one here is? Kalina said non-inverted. Is that correct? Yeah, Jacob, non-inverting correct? Well, why say that, Jacob? Why? Because the input is connected to the non-inverting positive terminal, right? Okay. Last thing. Last thing and we're done. How to find gain. You all remember the proof? You all remember the proof? For the inverted? Right? Let's do it for the non-inverted and we're done. Right. Everybody watch here? Pay attention to what is on. Everyone's too much trouble. Right. How do we find gain again? Gain is equal to V out versus V in. So all we need to do is to find the V out and find the V in. If I wanted to find V in, V out, I will connect my voltmeter here and here. Right? Here's V out and here's 0. Everybody okay with that? Here's V out and here's 0. So therefore, if I have current flowing, current will flow here, right? Would any current flow back here? No, because remember we call here virtual earth. Oh, nothing flows in here. So these two resistors are in what? Series. So it will be RF plus RI. Now, if I wanted to find V in, where would I connect it? Probably connect it here and here. But that's not so helpful, right? But if you remember we did the assumptions on the op amp? Right. One of the assumptions is that the input going into the op amp is what? Is it high or low? Remember, little goes in and plenty comes out. So therefore, these inputs are almost the same. So if I connect a voltmeter here and here, I will get the same VN value. Right? So VN is equal to I by RI. Power lamp to the eyes. And then you'll get RF on RI plus RI on RI. That will cancel. Huh? So you'll get 1. 1 plus RF on RI.
All right.
Okay? So this is the formula for gain. All right? The main thing I want you to remember in the proof is that the input here and here is the same thing. So if I connect a voltmeter here and here, you'll get the same thing. Okay? And the explanation comes from the assumptions I gave you. All right? So that's the way you find gain. So this formula here is a gain for a non-inverting op amp. All right? So I'm gonna give you some numbers here and you're done. Right? All I want you to do, Puma, all I want you to do here is to find V out and we're done. Right? Next week we do past papers on this and wrap up this part of the module.
So what's wrong?
Two. Minus two.
Wow.
Here we done, last minute. Just find V out and we're done. Right? So you gotta find gain, right? Gotta find gain and then find V out. Try that fast. And we are done. Ah. That's the first one. The proof any notes as well if you need it. Right, help me out here, because I'll take it kind of long. Shiny. What is the, how you want to call it, right? What's the gain of the first up arm? Non-inverting or inverting? Non-inverting, right? So it's 1 plus RF is how much? Over 10. So that's 100 over 10, that's 11, right? What about this? Inverting, non-inverting? You sure? Non-inverting, inverted? Inverting, right? So it will be minus what? That'll be minus 30 over 3. Right? So when you work it out, what you get? Minus 10 by 11, minus 110. Yeah? Sylvester? So the final answer is what? What's the input, Sylvester? What's the input? I give it here. 0.01, and the gain is minus 110. 1.12. Right? One line. Are you okay with that? Daniela? Katrina, you okay with this? Right? Remember to cascade, right? Alright, so that's it. Right? That brings us to the end of up arms. So we'll do a quick review and then we'll do some past papers on this next day. And then in module 2, we just have AC theory to do. Alright?